Okay, so let us start with probability distributions. So before studying probability distributions, you should know what distributions are, and in fact we can start even from the basics. So this all starts with random numbers. So what are random numbers? Or not random numbers, random variable. So what is a random variable? It is a function which assigns a real number value to the outcomes of the experiment. So this we already know what is a random number. So basically you have some sample space here. Suppose we are talking about tossing a die, right? So you have 6 outputs. One is you have 1, you have 2, you have 3, then you have 4 on the die, 5 and 6, right? So these are the possible outcomes of performing the experiment, tossing a die. So from this set, what you are doing, you are assigning a real number to this set. So that means you are associating this 1 to some real number here, this 2 to some real number here, 3 to the real number here, 4 to the real number here, 5 and 6, right? So here you are according to what is the definition of random variable, you are defining this mapping. So I have in the previous lecture I have told you about this experiment of tossing a coin, right? So when you toss a coin, you have two outputs. One is either you obtain head or you obtain tail. So in that case, if x represents the random variable and I assign the meaning to this random variable as obtaining tail, right? And we are supposing that only one coin is being tossed. So in that particular case, I am saying I have to construct the random variable corresponding to the sample space. So here what are your outcomes? You have only two outcomes. One is either you obtain head or you obtain tail. So accordingly, your random variable that represents obtaining tail. So we are counting the number of tails here as the random variable. So if you obtain head, there is no tail, so you can assign 0 number here, and when you obtain tail, so that means there is one tail, so this is the random variable here, right? So this is the one example where you are assigning random variable. In another example, suppose now you are tossing 3 coins. So in that case, what would be your sample space? In the first case, you can obtain head or head, because in the first case you can obtain head or tail. In the second you can obtain head or tail. In the third also you can obtain head or tail. Similarly, so we can have different cases that in the first trial you have all the heads, in the second trial you have tail on the third trial, then you have tail on the second trial, then you have tail on the first trial. So this is one possibility. Another possibility is that you have two tails. So we can have two tails like this, and we can have two tails like this. And in the third possibility we have the 3 tails. So these are only the possible choices, or we can say this is the possible sample space whenever we toss 3 coins simultaneously. So here, if x denote the number of heads that are appearing on whenever you are tossing 3 coins together, so what is your sample space or the number of outcomes? You can list it here. So it would be HHH, then HHT, and then HTH, then it would be THH, then it would be HTT, and then it would be THT, and then it would be TTH, and then last it would be TTT. So accordingly, the value of random variable here, because we are counting the number of heads, so here the number of heads, they are 3 in number. Here they are 2, here also they are 2, here also they are 2, here we have one head appearing onto this observation. Then here also we have 1, here also we have 1 head, and in this case there is no head, so we can assign the value 0 here. So this is our random variable x, and corresponding to this random variable I can also describe the probability. Here all of these events have the same probability of occurring. There are 8 of these observations, right? So all of these have the same chances of occurrence, so I can say the probability here is 1 by 8 in each of the following cases. So what I have done, I have associated with each element of the sample space a number which is known as random variable, and according to that I have defined the probability according to each of the member of the sample space. So this forms the distribution, right? So this is the very simple example that I have given you, where you can understand how we can define the probability distribution and how we can list the random variable. So before going into the details of this topic, probability distributions and random variables, so let us first discuss why actually do we need them. So the question here is, why do we need them? It is because in many real life applications we actually do not talk about coins and die, right? Because we do not really are required to make decisions on coins and these dies and cards and so on, right? However, what you are more interested in real life is to talk about whether so you are interested to make certain kind of predictions about something. So probability that give you the idea with which you can interpret the things. Which things? In fact, the random events that are occurring around you. Because actually in real life everything is random and we have a lot of uncertainty with us. Random events that are occurring around us. So therefore, using this probability, we can say what outcome will occur and with what chances. So we can also see certain examples here. So let me give you certain examples. So in this case, the first example you can see to be finances. Everyone has to deal with finances in their lives because that is the basic requirement. So if you are looking at the finances from the point of view of asset, or you are basically applying or buying certain stocks and shares, from that what you are to do, you are to see how much chances are there for me to get profit out of a certain deal, right? So there also you can see probability. Another example you could take this to be weather prediction. So in weather prediction, you are to see what are the chances that there would be rain today, or you are to predict the weather conditions in the near future. Right? Or if you are talking about advertisement, advertisement today is a very big industry. Lot of money is involved in advertisement. So here the role of probability is to estimate the potential customers that will more likely react positive, or we can say buy that particular product. Right? So it is very beneficial for the companies to have a analysis before launching or advertising about a certain product, that particular product. Right? So this is what we have. Now, as I've told you about random variable, so let's see what does it mean. So random variable is basically, as I have told you, assigning values to the elements which are present in the sample space and providing them with a certain number. Right? So here, how does this so we have this question, how does probability distribution helps, or why do we require to study all these? So as I've told you, first of all, what is a probability distribution? Probability distribution that is a list consisting of all the possible outcomes of a random variable. Along with its probability distribution. Right? For example, we have done here in this particular example. Here we have listed all the elements which are present in the sample space, and then we have written down the random variable here and the associated probability. Okay, so we have another example. So here, suppose we are collecting the type of blood group information from several different people. Right? So suppose a data has been collected. So according to that, your outcome would only be 4 because you have only 4 blood group type. So blood group type, it would be either you have blood group O, or you have it A or B or AB. So associated to that what is the probability? So you you go to different people, ask their blood group type. Suppose we are in some institution, and there we are talking to every member that is a part of that institution and noting down what is their blood group. So accordingly you obtain some number here. So there would be some numbers which could be written here. So there would be some people having this blood group this blood group, this blood group, and this blood group. And you also know the total number of persons there in that particular institution. So what you can do from these two data, you can calculate the associated probabilities. So suppose in the first case the probability is 0.30, in the second case it is 0.50, in the third case it is 0.15, and in the fourth case it is 0.05. So from here you have a basic idea that the people having blood group AB, they are very rarely found. So you can see from this probability. So from here you can make a conclusion here that in that particular area the people having blood groups are this much. Obviously there could be errors associated, but you have a clear-cut idea over here, right? And you can make predictions out of these data and studying these blood type. So here what you have done, you have instead of going for the whole city here, now if I ask you, you have this data, right? Now the next question is, if I ask you calculate the probabilities of blood group type of the whole city. So in that case what you can do, you can utilize this above data. How? Because in that whole city, suppose this is your city and there are several different people around here in this city, right? So what you can now do, you can take a very simple or very small number of elements out of these bigger city, so that you have few members of this kind, few members of this kind, and few members of this kind. So basically this is your sample and this is your population. So out of this whole population you have taken the sample, and in this case the sample could come out to be nothing but the people present in the institution. So therefore in this particular case what you can do, you have calculated the study and you can make you can predict various quantities based on this data. So you could utilize that, but obviously there would be some error that is associated here. So this has saved a lot of time of yours, so that otherwise you would go to individual person which is residing in that particular city, and you will then calculate the data, and then you will calculate the associated probabilities.